Hey there, ladies and gentlemen. Welcome to your first video done by Mrs. Matheson for Math 4. This is our first section of geometry. 1.1 Building Blocks of Geometry. Today's video is a ton of definitions, and really that's what our notes are today. And so you're expected to write down the definitions. There's going to be some examples throughout. The great thing about the video is that you can pause it, so you can take the time to write things down. You can rewind it. If you missed something that I said, you can watch it over, etc. This isn't just like watching any YouTube video where you just put it on, push play, and you kind of just zone while you watch it. This is to be involved, where you're taking the notes, you're pausing it. There'll be times I ask you to do things, so you're probably going to need to pause the video at that time also. Be an active participant in this so that you get all that knowledge. All right, so let's get started. Again, definitions today. We're going to hit a lot of definitions. So first one is a point. It has no size. It's only a location, and we name it with a capital letter. So for example, we have a point here, and I'm going to name it A. All right. And then when you go ahead to write it, for an example, in a problem or something, you just write the letter. Notice that I didn't put a point in front of it or behind it. It's just that capital letter. All right, the next thing we're going to talk about is a line. It is a straight continuous arrangement of infinitely many points. It has infinite length and extends forever in both directions. That's why we always put arrows on the ends of each end of our line, because it continues on forever. It's named by any 2 points on the line with a line over the top. So for example, if my line here had 2 points D and E, I'm going to write that example out and label it as such. If there's a third point on the line or more than that, you can name it by any 2 points on the line. It doesn't matter which two. So we could have DE, DF, EF. Okay, all of those are going to be the same description for this line. All right, a plane has no length, or has length but no thickness. It's a flat surface that extends infinitely along its length and width, represented by a four-sided figure that's slightly tilted, you see up in the corner there. It's created from 3 or more non-collinear points, and we're going to actually get to what this collinear means and non-collinear means in a moment. So plane, we always kind of use a parallelogram, a little slanted rectangle to describe it when we show it in pictures. And it's named by a script capital letter. Okay, so it's kind of a cursive capital letter. You'll find it in the corner of it. We also can describe planes by the 3 points that are on it. And remember, they're non-collinear. We'll talk about that. So we could have plane A, B, C. We could have plane B, A, C. Any combination of those 3 points can make the name for the plane. Planes are seen a lot in real life. So for example, we have this sidewalk here. That's a plane. We have the grass over here. That could be a plane. We have the flower bed here. There's a plane in this picture. So lots of planes just in that picture. Here's an example of the football field. We have the plane of the football field. We have the plane of the building up in the back. We can talk about the plane of the sky. So planes are in lots of places here. So even if you just look around in your classrooms or your hallways, your houses, floors are planes, walls are planes, ceilings are planes, windows are planes. These ones do have end points, you could say, where they end, where they meet the wall, but they're an example of a plane. All right, so here's a good example of the plane, and here's a map. And this plane actually is going to show multiple parts of what we've already talked about. We've talked about planes, points, and lines. So we have examples here of planes, points, and lines. City blocks here are planes. This whole map can be considered a plane. Lines, we can look at streets are lines. Okay, this example gives us some points here where we have some different diagrams there, points on the roads, etc. So this map has lots of lines, planes, and points that we've talked about. That brings us back to that word collinear. Collinear means on the same line, and you'll actually see the word line in collinear, so that helps you remember it. Um, in this example picture here, A, B, C, and D are all collinear points. E, F, and G are not collinear with those four other points, but if we see here, I could draw a line here, and F, C, and G are collinear, or E and A are an example of collinear. They can be on the same line. We also have what's called coplanar, and that means they're on the same plane. The word plane isn't totally quite in there, but it's close. So this will help you remember coplanar means on the same plane. So here in this diagram, we have two intersecting planes. E, G, O, and B are coplanar. F, A, L, I, and C are all coplanar. Either they're on this plane or they were on this plane here. Okay? All right, so here's an example picture when we talk about collinear and coplanar. If you want to look at this more in depth, it's on page 30 in your books. Name 3 tennis balls that are collinear. So you'll see a bunch of tennis balls that are labeled. I want you to name 3 tennis balls that are coplanar but not collinear. So they lie on the same plane but not on the same line. And then 4 tennis balls that are not coplanar. So 3 of them can be coplanar. That 4th one just needs to not be coplanar. And that one might be a little bit more tricky. So I'm going to give you guys some time right now to take a moment, look at the picture. You can go ahead and push pause. All right, let's see what you came up with. 3 tennis balls that are collinear. All right, 3 tennis balls. That means that they need to be on the same line. So we can talk about B, D, and G. So find B, D, and G. Did I cut G out of the picture? A, B, C, D, E, F. G. G is over here. Sorry, missed that. That's going to be hard. B, D, and G. Those ones are going to be collinear. Or another example would be E, F, and G. These ones are going to be collinear. Coplanar but not collinear. So any 3 balls that don't line up together. 2 of them can, but the third one doesn't have to. So you could say B, C, and D, C, D, and G, E, D, and G, F, D, and G, B, E, and G. Any of those combinations. And then non-collinear or non-coplanar points, 4 of them. So pick any 3 points, and then the one that makes it non-coplanar is this little tricky one here, A. A is technically in his pocket, so that puts it not lying on the ground. So then therefore that would be non-coplanar. Or you can talk about C. C is up in the air, so that one would be non-coplanar. All right. Line segment. A line segment consists of 2 endpoints that all the points between them are collinear. Endpoints give us an end to our line. So for example here, this line segment does not extend indefinitely in each of them. They have endpoints. Okay. Line segments are named by the 2 endpoints with a line segment above the 2 letters. So here, line segments are always named by the 2 endpoints, none of the points that are listed in between. Okay, so for example, this would be XY with a line segment above, not a line, so no arrows included there. All right, so then that brings us to congruent segments. In geometry, we talk about congruent, and that means that they have the same measure. Okay, when you talk about numbers, numbers are equal, but when we're talking about geometric parts, those are going to be congruent. Numbers such as 4 equals 4, that's an equal. If you see here, we have AB is congruent to CD. A congruent symbol is equal sign with a little swiggle above it. Okay, congruent can be like MN and PQ, where they tell you that their measure is the same. Or it can be like WX and YZ, where they mark it off with lines, okay? Those lines are going to indicate that two parts are congruent. You could have it marked with one line, you can mark it with two lines, or with three. But you wouldn't want to have one with two and one with three because that's going to represent that they're not congruent to each other. Okay, congruent. They have the same measure. We'll use that a lot. That brings us to midpoint. The midpoint on a segment is the same distance from both endpoints. Midpoints occur for segments, not for lines, because remember, lines extend indefinitely. Okay? The midpoint is going to bisect the segment by dividing it into two congruent segments. So you'll see here, B is my midpoint for this line segment, and it's shown that it's congruent pieces by these lines here. You could also have shown it by this saying this is 18 and this saying this is 18. That also would imply that B is my mid segment, or B is my midpoint. All right. Ray. A ray begins at an endpoint and extends indefinitely in one direction. So this has a starting point and it keeps going. Okay, it's named by the endpoint and a point contained on the ray. It's noted by the endpoint first, and then we do the second point with a line drawn, a ray drawn above it. So in our example here, here's our endpoint, and let's put some points on my line. All right, so I can denote this by a B. See how I have one arrow? I can denote this by a C. I can denote this by a D. They are all referring to that exact same ray. When you do the notation, you always start with your endpoint first, and then some other point that's on your ray in addition with it. Okay, so that brings us to your practice. Your practice for this section is going to be page 33, 1 through 31. So all of them are expected to be done. We'll be coming to class and I'll go through questions. We will talk about any questions you might have on the notes or on the work, and then we'll grade it, and then you'll be able to get started on your next video, your next assignment. We'll see you guys then.